Okay, good morning class. So at this point we're looking at equations, quadratic equations and inequalities. We are on exercise 2.6, 2.7. Okay. And 2.7 is on page? Okay, so now we're looking at practical applications of finding maxima and minimum values. Maximum and minimum values. Let's take this off here, I need some space. Otherwise we're intruding in the next section. This is the example on page 30. Alright. So we are told that the farmer plans to construct a rectangular enclosure for his sheep using 100 meters of fencing. He makes use of an existing boundary wall as one of the sides of the rectangular enclosure. Thank you. Calculate the dimensions. What does dimensions mean? The length, no? The length, the dimensions of the rectangle, so that it can get a maximum enclosed area. So that is what happens in the reality. Okay, we always want to maximize space, okay, and minimize. What would we like to minimize? Cost. Not so. Maximize profit, minimize loss. Not so, people. And that is what we are trying to do in this case as well. Okay. So, if you're using fence and you want to make a rectangular fence, he is not going to put fence across in front of that wall there, against the wall. No? There's nothing wrong with the farmer yet. Okay, and what he's thinking. Of course, he's not going to put the fence or parts of the length of the fence against the wall. Not so. Sometimes it will be a wall, sometimes it will be a stream. Okay, we want the sheep to drink. Not so, for the cattle to drink. So, if it's a stream again, then they also wouldn't corner it off like that. Okay, wherever, whatever. Alright, or a mountain, whatever the case might be. So, this thing doesn't it looks like it stopped working. Okay. Alright, so this is the scenario we have here. Not so. So if that wasn't given, what I would have done was I would have made that the wall, and that would have been my rectangular shape that's being formed. Not so. So what we do is the question says we are given 100 meters of fence. So the perimeter along this would be 100 meters. Or he has 100 meters of fence. Not so, people? Okay. So what we do is we call the one side x and the other side y. So calculate the dimensions of the rectangle so it can get a maximum enclosed area. So if you look at this here, the area, how do you work out the area of a rectangle? It's going to be length times width. So what I'm going to do is, I'm going to get the length and the breadth in terms of the same SI unit. And this is the same variable, sorry. Okay, so what I did was, we made the one side x and the other side y, as you can see here. Okay, I had to actually cut this out and I could have just drawn it myself. But anyway, so if you're looking at the perimeter, if I start here, it's going to be x plus y plus x. In other words, it's going to be 2x plus y. But 2x plus y is also equal to what? 100, yes. Why? Because that's your perimeter. So it's going to get 2x plus y is equal to 100. So in this case, I'm either going to make x the subject of the formula or y. I'm going to make y the subject of the formula. Okay? So that we can work with x's. So y is equal to 100 minus 2x. And this is this length here. So how do we calculate the area? We said area is equal to length times breadth. And what is my length here? 100 minus 2x. And what's my breadth? So what happens here, I can now multiply this here. So that's going to give you negative 2x squared plus 100x, or 100x minus 2x squared. Okay. Now, yesterday's lesson, which was 2.6, huh? What did we do when we calculated out our turning point, our maximum values, maximum, minimum? We needed to complete the square. We needed to get it in that form. Once it's in that form, we can read off our maximum and or our minimum values. Not so. So if I complete the square here, so it's going to be a is equal to negative 2x as a common, negative 2 as a common factor, although x is a common factor. I'm not going to take that out. So that's what I will be left with at this point. You all agree with that? Who's confused at this point? Nobody? Okay? Put your hand up. What are you confused about, Michael? The square. No, I didn't complete the square yet. Okay? So now I'm going to go in completing the square. Remember, for completing the square, the number in front of x squared must be 1. So was it 1 here? No. So I took out whatever the coefficient of x squared was. Okay? It doesn't have to be a common factor. Whatever the coefficient of x squared is, I take it out. Okay? And I ask myself, okay, what must be added here to complete the square with? Is the same number I must subtract again. What's the number, Michael? B times 1 over 2 is squared. So what is B in this case? 50. 50 multiplied by half? 25. So it's going to be 25 squared, which is 620. You understand, Michael? Right. So what happens now? What do you see inside this bracket? Perfect square trinomial. Perfect square trinomial. So we got negative 2 into x minus 25 squared minus 625. You all agree with that? Now what do we do? Multiply the negative 2 in. Okay. Multiply the negative 2 in. It's then going to give me negative 2 into x minus 25 squared plus 1250. Now, would this have a maximum or minimum value according to this negative in front of the 2? Maximum. Can you see? And what was the question? Maximum area. So to answer this question is, therefore, the maximum area of 1250 meters square. How do I know it's meters square? Because the dimensions was given in meters. And area is being squared. And occurs at double C, no? You are, yes? Occurs at an x value of 25 meters. Okay, so what is the length? So that is x, which is the breadth, not so. So what is the length? The length is, let's go in terms of x, what's the length? 100 minus 2x, not so. So that's going to be 100 minus 2 times 25. What's 2 times 25? 50. 100 minus 50? 50. The area of 1250 meters squared and occurs at a breadth of x and a length of 50 meters. That's the length. Okay. And 50 times 25 is 1250 anyway. If you go and you divide this length up of 100 meters. Anyway, say you go and give the breadth 20, so it's 20, 20. Then what are we left with as the length here? 20 plus 20 is 40, so it will give me 60. So what would the area of that piece be? 20 times 60. And what's 20 times 60? 120, 100, not so, which is less than this. Can you see that? Let's choose 10 and 10. So it's 20, and then what do we left with here? 80. What's 80 times 10? 800. You can choose any values making up that combination. It will never exceed this maximum value of 1215. Does it make sense? Okay. You guys understand? Okay. So at this point you should be able to do exercise 2.7, and that's on page 31. I'm going to stop the video at this point. Any other questions?